Okay, calculus, we're looking at number 38 for the step by step. Someday, hopefully, you guys will watch this show. It's called Step by Step. From back in the day, TGIF type of TV. All right, let's figure this out. They give us f prime of x. They give us this piece here. So what are we given? We are given f prime of x, and we're also given, f of c equals d kind of thing, or f of d equals c. So what does that usually do? The second half here means that we're going to solve for a constant of some kind. That happens a lot. Is there any formatting that's interesting? Okay, so something I see in the format, I know that if I have f prime and I'm going to find just f, that means I'm going to be doing an antiderivative. I also notice something interesting here, that there are layers to this function. We got an inside layer and an outside layer. So we got to consider, how is that going to affect our antiderivative? Well, let's see what we can do there. So the question then, what's the question? The question is saying find f of x. F of x equals something. But that involves an antiderivative and then also solving for the constant. Solve for the constant. Let's do it. So we're going to take the antiderivative of 1 over square root 2 times x plus 1. dx, of course. Okay, a couple things about this. We notice that we had layers. When we see the layers, that means the inside is going to be our u for the substitution. So we have u equals 2x plus 1. If I take the derivatives of both sides, that gives me du dx equals 2. Now, when I'm looking at what I have here, I don't have a 2 anywhere, but I do have a dx. So let's go ahead and make a substitution and see what we have. I'm going to have 1 over square root of u dx, which is the same thing as u to the negative 1/2 dx. So the u to the negative 1/2, that's going to be easy enough to deal with, but this dx doesn't work for me. Doing some algebra, multiplying both sides by dx and dividing by 2, or multiplying by 1/2, I would get du over 2, or 1/2 du equals my dx. So now I got to make another substitution here. We're using these u pieces here. So now this will be the integral of u to the negative 1/2, but I need another 1 over 2 and a du in there. Now I'm ready. Why? Because my variables match, and I can work my way through this problem. So the antiderivative of u to the negative 1/2, pardon me, I'm going to add 1 to that power. That gives me u to the positive 1/2. I got to divide by that 1/2, and then I also have another 1/2 out here. 1/2's all over the place. But I am missing something. Notice that I did not have limits. I didn't have an a or a b, so that means I need a plus c. So this is f of x so far. What's missing? Well, it's in terms of u instead of x. And I need to use that given value, f of 0 equals 2. That's going to be important. F of 0 equals 2. So let's do some simplifying. If I take this 1/2 and this other 1/2 here, then I can kind of flip that 1/2 to the top, and that's going to give me, what is that going to give me? That's going to give me just 1, 2 over 2, so that's 1 times u to the 1/2, which is square root of u, and then plus c. So square root of u plus c is equal to f of x. We know that f of 0 equals 2, but u is not just u here. That's really an x term. So let's see what that is in terms of x. Square root of 2x plus 1 plus c equals the f of x. Take it a little bit further. Now we're going to plug in 0. So, and that's going to be equal to 2. So we plug in 0. That'll be 2 times 0 plus 1. And we got plus c. So what would this come out to simplify here? We'd have 1 plus c equals 2, c equals 1. Technically, I'm done. I am done because I've been labeling my work throughout here, but just to give a conclusion answer, f of x equals, well, we have this piece right here. We're going to have square root 2x plus 1, and we got plus 1 on the outside as well. Right, that's a good thing. We finished it. Check, done. Let's see what else we got going on. So for part B, if we scroll up here, find the value of c guaranteed by the mean value theorem on 0 to 12. And of course, we're talking really about f prime. So in other words, we're going to be talking about the integral of f prime of x dx from a to b. We're going to be dividing by that range b minus a. Now let's translate these pieces here. So here's our a, here's our b. That means that we're going to have the integral from 0 to 12 over 12 minus 0 down here. And then f prime of x was 1 over square root 2x plus 1, and then dx. Now, thankfully, we actually did this integral already from part A, so I know what that simplifies to be. That's just square root of 2x plus 1. And then we got this plus constant, but that doesn't happen. Whenever you have definite integral, there's no plus c for definite integrals. So we don't need that. So here, this is going to be equal to 2x plus 1 evaluated from 0 to 12. Again, divided by this bottom piece, which in this case is 12. Let's keep working it here. That's going to give me, if I plug in 12, we're going to have the square root of 2 times 12 plus 1 minus square root of 2 times 0 plus 1 all over 12. Keep going a little bit further. The first one's going to be square root of 25. Second one is the square root of 1, and then over 12. Keep going. Lots to do here. Square root of 25 is 5. Square root of 1 is 1 over 12. This is going to be 4 over 12, which is 1/3. Now you might be thinking, why did you simplify that the whole way? Here's why. Because is this the actual thing that it was asking me to find? It was. Now, if it said x value, that would have meant, say that f prime of x, or no, f of x, right? No, f prime of x in this case equals 1/3, and it would have asked us to say x equals what? But because it's the c value, that's saying that this mean value is going to be equal to c. Now, I know that this seems a little kind of ambiguous because we have this plus c, which stands for a constant, but then you have this c, which is also a constant, but not the same kind of constant. So we got to keep in mind that the c value is just really asking us to do the integral from a to b of f prime all over b minus a. Not a huge deal, but we worked it out here. C equals 1/3. Let's see what the next piece asks us to do. So now it's asking us same kind of process, but something much more advanced, because it's almost got like we have a variable inside of it that we're not even sure about. So it says that there's some number k, and k is a positive number here. That's what k greater than 0 equals. Such that the average rate of change of f on 0 to k is 1/2. So the average rate of f is really saying f of b minus f of a over b minus a. And they're saying that that is going to be equal to 1/2. Okay, think about this. b and the a, what are those numbers? Well, in this case, here's our a, 0, and our b is k. It's actually a constant that we're going to plug in and figure out what its value is. So let's figure out what f of 0 is. Remember that that's the, what do we have this? We have an f of x in part A here. It's really this piece. Let's take a picture of it. You would have it on your paper, but I have it on different screens. So I'm going to take a picture with board. Paste. Okay, so we have this function. It's very helpful for us to see that we get that function. Let's erase this piece. There's f of x. What would f of 0 equal then? F of 0, if we plug in 0, that's going to be 0 plus 1 square rooted. And we got another plus 1. And that's going to equal 2. All right? And that's for my a. And then what's b? Well, that's going to be k. So that's going to be f of k equals square root of 2 times k plus 1. And then we got this other plus 1. And that's f of k. So let's plug in these pieces here. Remember, the b is our k and the a is our 0. So that means that this would have to equal 1/2. So we have square root of 2k plus 1. And we got another plus 1. That's our f of k. And the f of a we figured out was 2, so it's minus 2. That's going to be over k minus 0. This has to be equal to 1/2. Okay, so we got a little bit more going on here. Let's see what else we can figure out. This really is just a bunch of algebra from here. We see plus 1 minus 2 with these two constants here. That's going to be a minus 1. So that gives me square root of 2k plus 1 minus 1 all over k is equal to 1/2. All right. At this point, I would like to multiply the k to both sides. That's going to give me square root of 2k plus 1 minus 1 equals k over 2. Now when I'm at this point, there's a few things you could do, but I'm going to move this 1 over and then get rid of that square root, because really this square root is the hardest piece to get around. So I'm going to move this 1 over, and what would we get there then? So we move the 1 over, I'm going to add 1, add 1. That would give me square root 2k plus 1. Now I'm going to make this kind of almost like a fraction, just to keep it a little bit easier here. So that's going to be k plus 2 all over 2. Now at this point, I can do some squaring, and let's do that. So I'm going to square both sides. That would give me 2k plus 1 on the right equals, now on this side it's going to be a binomial times a binomial. That would be k squared plus 4k plus 4, and then all that divided by 2. Now think about this for a second, guys. Or divided by 4, pardon me. If I squared this other side, how did I get that? Well, that's like doing a box multiplication of k plus 2 and then k plus 2. You'd have k squared, 2k, 2k, 4. You put it all together, you get k squared plus 4k plus 4. Okay, so let's multiply this 4 to both sides. We're going to need almost a new page. Let's go to a new page. Let's not wait. New page. So we multiply this 4 to both sides, so that means I'm going to have 4 times 2k plus 1 equals k squared plus 4k plus 4. And at this point, I can distribute. And then I'd have 8k plus 4 equals k squared plus 4k plus 4. I could subtract 4, subtract 4. And then I'll have subtract 8k, subtract 8k. What would we get? We would have k squared minus 4k equals 0. So let's keep going here just a little bit further. I can factor this. K times k minus 4 equals 0. So what are the possible answers? We could say k equals 0 or k equals 4. Now, we got to consider, are both of those answers possible or just one of them? Well, remember that in the original prompt it said find the value of k greater than or equals 0. So see, average rate of change on 0 to k, so that means 0 is where we start at. That means k needs to be somewhere beyond 0. And k has to be greater than 0. It even mentioned that. So k has to be greater than 0. So this is out. But k equals 4 is a possibility. Now, is there a way that I could have done that with a calculator? You betcha. So I'm going to show you something here with the y equals. Let's say that we had each of those, or we just had one function in here, the first one, but it's a kind of a big function. It's the numerator. So we would have the numerator, and in this case we put 2 times the variable, or square root, pardon me, second square root, 2 times the variable plus 1, and we had another plus 1. So that was our numerator, and in the denominator was that variable, in this case x, minus 0. And that was, instead of x's, we used k's. And then we wanted to set that equal to 1/2. We wanted to figure out when did that cross 1/2. And it looks like it crosses at 4. But let's check out our graph and see what we get. Okay, so we're off the screen. We need to change our window here. We need to go to at least 4. If I'm going to go further than that, let's go, or let's go from 0 to 12. That's our interval, 0 to 12. Now I'm going to go negative 10 to 10. How about negative 5 to 5? Negative 5 to 5, just to give me some decent range to look at. So there's my function, and where do I cross? Is this where it equals 1/2? Let me double check and make sure I set this up right. So we have 2k plus 1. Oh, I forgot this minus 2 in there. That is very important because it wound up being this 2k plus 1 and then minus 1. So if I go back to my function, y equals, I knew something was off. Instead of this being a plus 1 here, this would be a minus 1. There we go. So now I go to my graph, and that looks a lot better. It looks like we do cross, in fact, at around 4. It's really hard to tell, though. Really hard to tell. So maybe I can just calculate it. Second, calculate the intercept. We know that it's somewhere around here, so literally, I'm just going to kind of guess. Blank. That looks close enough. Guess. Do we have an actual? Yes! Right here at x equals 4 and y equals 1/2. There's an exact value. So again, you can use your calculator to find the intersection between two values. I have an equation. This side is a function, some type of function, f of something, in this case f of k. Well, I shouldn't say f. It's a function. And over here, this is a constant. And if I want to see when does a function equal a constant, I graph both and find the intersection, because the intersection tells me when they're equal. And in this case, it happens to be at k equals 4. Check done. That was piece of cake. So we have lots of stuff going on here, and there's lots of different ways. There's actually more than one way I could have done this part C. This one was just trying to keep it pretty straightforward when we know the average rate refers to this piece here. And keep in mind that was the same thing as doing the integral from a to b of f prime of x dx all over b minus a. Same thing. Same thing. It doesn't matter whether you treat it like integration or a derivative. One of where there's like the integration version or the derivative version of mean value theorem. Because I had already figured out f, it was probably a little bit easier to use this one here on the left. So I didn't have to do the antiderivative and then calculate a and b and all the other pieces. I would have come out with the same thing and just using a little bit of a shortcut there. Okay, so I know that video again was a little crunched on time. Try to watch it more than once if you can. If you guys have time in class here, feel free to ask somebody else to go over it with you as well. We will see you in the next step-by-step free response video.